Hello, Algebra 2 people, and welcome to the last chapter of the semester, Chapter 5, all about exponents and rational exponents, radicals, simplifying radicals. So we're going to start off with a little bit of notation. We're going to be talking about roots. So you are used to taking a square root, which looks something like that, and we are going to introduce a new notation. Now, you don't usually see the 2 in the radical because it's the default, just the same way we don't show a plus before every positive number. But if I have something underneath that radical, that is equivalent to writing it as 1/2. So that would be a rational, because it's a ratio, rational exponent, and it also goes with a radical notation. So this would be your radical notation, and this would be your rational exponent, and they are equivalent. And so what we're going to be looking at is not just square roots, but cube, quarter roots, 2/3 roots. We're going to be looking at different values in this section, in this chapter. Okay, so here we have how you can write your radical as a rational power. So the first thing we want you to do is just get used to going back and forth. So here we see the cubed root of a, which we could also write as a to the 1/3. So an example of something like that would be the cubed root of, let's say, a -8. And what that is asking is what number, when you multiply it 3 times, gives you -8? Well, the cubed root of a regular 8 is 2, so the answer here is going to be a -2, because -2 times -2 times -2 is -8. The 4th root of a can also be written as a to the 1/4. And so again, an example of that would be if I were taking the 4th root of 16. You'd ask yourself, what number, when I multiply it 4 times, gives me 16? And again, that answer would be 2. These numbers can get huge really fast, which is why I seem to keep choosing the same root here. Let's say I have the 5th root of a, which we can write as a to the 1/5. And again, that would look like this. And if I put in a 32 here, guess what the answer is going to be? It will be 2. And then we have the 6th root of a, which can be written as a to the 1/6. And I'm not going to give you, oh, actually, no, that's fine. So I think you have the idea. All right, so you can write the radical as a rational exponent. So a couple of the properties that we can talk about when you're doing this, and I definitely want to go over this next box because there's something that's not exactly accurate here. If the number under the radical is a negative, and we have an even, we're taking an even root, like the square root, the 4th root, the 6th root. So if a is a negative number, for instance, if I was trying to take the square root of a -9, in this case, we're going to have no answer because we know that the answer would involve an imaginary number. In this section, we're not going to have imaginary roots. Okay, so you're allowed to just say no solution. If a is 0, well, that's a nice easy one. The square root of 0 is always 0. If a is greater than 0, so let's say I was trying to take the square root, or let's be a little more, let's do a cubed root, say, of, oh no, I wanted an even, sorry about that, forgot about that, that was a whole idea here. So we want to have ourselves an even, so the square root of +9. Now here it is saying that you have a plus or minus. That's not going to be the case. We just want you to take out what's called the principal value, which would be the positive. So the square root of 9 is 3. It's a positive number. You don't have to do the plus or minus unless you're solving an equation. When you're simplifying, you just pull out the principal value. what I want to point out here is if I'm taking the square root of x, so this is an even power, when it comes out, it has an odd power here. So I went from an even root to an odd power. You put absolute value signs. And don't worry about this too much. It'll come up again. I just want to plant that seed right now, that when it's a variable, we want to ensure that what came out was the principal value, which is positive, and so it would come out with absolute value signs. And we will make a deal about it when that comes up, okay? On the other side, if n is an odd integer, because when you multiply negative numbers, it's actually okay to have a negative under the radical. For instance, if I'm taking the cubed root of -8, I don't get a no solution. I actually get a negative number because -2 times -2 times -2 is a negative number. And again, if it's 0, that's totally okay. You still get 0. And if a is positive, you don't have to worry about that whole absolute value thing. The cubed root of 27 is going to be 3. The cubed root of x is going to be x to the 1/3. There's no absolute value needed. It's only going to be over here, and we will talk about that as that comes up. Okay, so let's practice with a few of these. So we have the cubed root of 216. Now hopefully you guys all have your little chart that you can then look up, because you're not going to be allowed to use a calculator on these. Otherwise, you're just using a calculator. So you can look under your cubes and find 216, and you find that 6 cubed would give you a positive 216. So this means that the cubed root of a negative 216 will end up being a -6. Why is that? Because we have -6 times -6 times -6. That equals the 216. So I could rewrite this as -6 cubed. And just like with square rooting, this and this cancel each other out and leave us with the -6. So if we do that with the 4th root of 81, well, the 4th root of 81 is 3 to the 4th. And then this and this cancel, and we're left with a positive 3. Now we come over here to the square root of -16. Since this is an even root, that means we have no solution. I shouldn't have put that means. We have, it actually equals nothing. Okay? Okay, so now we're going to move away from just integer roots or integer exponents and look at what happens when you have a fractional power. So it's a mix. What you have is the top number represents a power or an exponent. It makes the number bigger. What you have on the bottom is a root. Just as roots are underground, roots are also going to be the denominator. They make things smaller. So notice you can then separate 1 over n times m. The power goes on the outside because it's an exponent, and the root can go in the crook of the radical. I don't know if that's an official term, but that's what I call it. So for instance, if I had 8 to the 2/3, I could rewrite that as 3 goes in the radical because it's a root, and this is 8 squared. Now it doesn't matter whether you write it underneath the radical or not. I could also write that as cubed root of 8, that whole quantity squared. They mean the same thing. If you have a negative here, remember a negative has nothing to do with the positive negative of a number. It means take the reciprocal. It's an action button. So same thing would be the case. Now you have the reciprocal of 1 over the nth root of a to the m. So for instance, if I had 25 to the -1/2, that's the equivalent of 1 over 25 to the 1/2. That's what the negative means. And I could also write this as then the square root of 25 or 1/5. Okay? And again, notice we don't put that 2 there. It's our default. It's up to you whether you want to include it or not. All right, we're going to evaluate each expression. So what I recommend, always, always, always start with the denominator because it makes the number smaller, then raise it to a power. So for instance, we have 16 to the 3/2. That's equivalent to 16 to the 1/2 cubed. Well, 16 to the 1/2, remember, is taking the square root of 16 and then cubing it. So this is going to give me 4 cubed, which is 64. All right, and again, you can use your root chart if you're not up on what 4 cubed would be, but doing the process, we don't want you just to plug the number into a calculator. Okay, so 32 to the -3/5. So what I'm going to do is 32 to the 1/5 first, and I'm going to leave that -3 outside. So the 5th root of 32, that's what we're doing here, we did that one up above, is going to give me 2. And then 2 to the -3 is like saying 1 over 2 cubed, which is the same thing as 1/8. And that would be our answer. Okay, so notice if you do the bottom number, the denominator, it's a root, it makes the number smaller, so then when you raise it to a power, you don't need a calculator because it's just a number that's more familiar to us. All right? Now, having said that, not using a calculator, it's still important to know how to do these with a calculator because sometimes you're not going to have a nice exact answer. So what you should do is look on your calculator, depends on your calculator, and we'll have to do this more in class and look at what you have. There should be a caret key. And if you're entering a rational power, you want to then enter it in parentheses. So for instance, if I was doing 2/3, I would then hit 2 divided by 3. So let's say I was doing 8 to the 2/3. That's equivalent to this, and that's how you could enter it on the calculator. You don't actually need a calculator for that particular one, because that would give me 2 squared, which is 4. But go ahead and try it and see that you do get 4. So we're going to try these. So the 5th root of 9, now some of you also have a key on your calculator that looks something like this, or it might have a little X in the crook of your radical. And in that case, you enter the n first, you would enter 5, then you would hit that key on your calculator, and then you would enter the 9. And now this is not going to be an exact number. The other way to do this is you can just enter 9 with your caret key, parentheses 1 divided by 5. Either way, hopefully when you do that, you should get 1.552. So make sure that you're able to do that correctly on your calculator. You might even want to pause this while you go through and try these. 12 to the 3/8. So first thing you're going to probably want to do is rewrite this. So this is 12, the power is 3, because that's the exponent, divided by the root. And so if I'm entering that on the calculator, if I want to use the caret key, then I'd have 3 divided by 8. And hopefully you're able to do that and get 2.539. All right, so if it does call for a calculator, it is important that you know how to do that. But most of the time, we're going to be giving you numbers. In the homework, you may have some that you use a calculator. On quizzes and tests, most likely, you're just going to use your power chart. Now, one of the things you can do with these is solve equations that come with fractional powers, which is quite common. So one of the strategies is always isolate the exponential term, and then whatever the power is, you're always going to then raise both sides of your equation to the reciprocal power. So let's see how this works. So we have here 4x to the 5th. We want to isolate x to the 5th, so we're going to divide both sides by 4. So I have x to the 5th equals 32. And I'm going to now raise both sides to the 1/5, because that cancels this out and leaves me with just x. And on this side, the 5th root of 32, you don't have to write it in radical, I'm just emphasizing that they mean the same thing. That is going to be 2. And that would be our answer. Over here, we already have our power isolated. So I'm going to rewrite this problem just so I can show the work on it. So we have x minus 3 to the 4th power equals 21. So the reciprocal power would be to take the 4th root of both sides, because that will cancel with that. And I have x minus 3. And now the 4th root of 21 is something I'm going to need to go to my calculator with. Now, if I asked for an exact answer, what you could do is just go x equals 3 plus the 4th root of 21. But at this stage, that would be an exact answer. If you wanted what the equivalent was, I would go to my calculator and find out that that is 3 plus 2.141. So x equals 5.141. All right, so welcome to rational exponents and radical equations, and I hope it's an enjoyable last chapter.